Okay, am I audible? Am I audible, Shubham? Am I audible? Hello.
Yes, sir.
Okay, fine, fine. So, okay, I'm sharing a screen with you. I hope it is visible to you all. Okay. So, is it visible? Whether my screen is visible to you all? Okay, fine. I hope it is visible to you all. Okay, so actually in last few lectures, we had completed and almost our all syllabus. So now we are moving towards the revision part. So as we all know the syllabus structure, and now we'll move towards the our unit number first, and we'll go a little bit revision on that. Okay. So important thing in case of these first chapter, that is about the whatever be electrostatic fields. Okay. So in that electrostatic field, what we will see, we will understand that whatever be uh, electrical stresses, electrostatic stresses are there, then whatever be the we can say like a gas vacuum insulator, how they used as a medium, also liquid breakdown, what does it mean by, then solid breakdown, estimation and control, and surge voltage and their distribution. So we will understand that all things one by one. So before going for that, you should just keep in mind that whatever be the our study that we are going to understand, that is only revision. Okay. So here as we know that everywhere there are various applications, and that applications to in power system. So we will cover the high voltages. So as we know that there is a modern civilization, and due to that there is a again high research laboratories are required, right? So due to that requirement of the laboratories, what is happening, that whatever be the power we are carrying or transmitting from the bulk amount, that need to be indispensable. So in that cases, our that whatever be equipments we are using, that should be tested, and that should be have a proper quality assurance, right? So the simple again here, the gaseous, whatever be the medium that are used for the insulation, that are gases, vacuum, solid, liquid, and sometimes we can say the combination of the all. There will be a whatever be mediums are there, we understand. So in such a first chapter, that we will understand how these general principles has been used and all that things. Okay. Then in next, that we will see what is exactly that electrostatic stress. So means, as we know that in a mechanical design, so whenever we are designing any kind of the whatever be a we can say design we are doing, like at that time, suppose for the high voltage applications, we are designing a insulation medium, or we can say whatever be the uh, electric field stresses that are going to develop whenever we are considering as a part of as an important factor in point of view the high voltage system. So whenever our conductors are carrying a current, at that time there should be a insulations on that conductors, because to provide the outer leakage of this current, or we can say to provide the leakage of the current to the whatever be undesired paths will be there. So for that purpose, we can say whatever be the insulation will be there, that should be have a very good electric stress, as well as that materials should be equally numerically equal to the whatever be gradients are there. And that gradients, we know that that is here which is around a, we can say it is a E is equal to minus del phi. So here del, we know that it is a operator, and this is known by the dou x, right? So that is the operator. And the second thing, that is electric field intensity, we know the E, and the phi, that is for the whatever be the applied voltage. So That way we can find out easily, and that equation I think you have understood in a vector or linear algebra. So such way you can find out whatever be the intensity is there, right? Then whatever be a electrostatic stress, we can see that suppose if suppose at a particular voltage level at which suppose the current is starting to increase for the very high value, so that should be controlled, and that should be controlled with the help of only external impedance. So we need to improve, or we need to add the that circuit into that impedance circuit into the our whatever be voltage system we are developing. So in that cases again there is a electrostatic breakdown and such kind of things that we need to think, and in that case there is important thing, that is the insulating material. So there should again have a various properties like a pressure, like a humidity, like a temperature, like a field configuration, how what kind of supplied voltage is there, then imperfections in a dielectric materials, what kind of electrodes that are being used, then what is the surface condition of the electrode. So all the things they will understand, they will think about that, and then we can say how our equipment will perform, how our equipment will be a response to these such things, and then and only then we will get the value for whatever be electric breakdown strength we need to calculate. So whenever we will understand whatever be the failure of a insulation, so that will be possible only when there is a not a proper whatever we can say insulation failure. Means what? Means if suppose there is a discharge, or at a particular point if there is a breaking a conductor, that time there is a discharge of current, so that is nothing but what? That is nothing but insulation failures, right? So in such cases, when we can say that that kind of insulation failures will occur, so we can greatly say that if suppose whatever be discharges we have, if suppose that eliminated at a working or normal working voltage, so that time we can easily say there should be not a thermal as well as electrochemical deterioration. So this is all about the whatever be a we can say it is a uh, electrostatic stress. Then the second unit we had seen that again in such cases we had seen second time, that is gas and vacuum as an insulator. So that was our second point in the first unit. So in that cases what we have seen, there should be a breakdown strength of these gases which is very good, and there should be a gap between whatever our electrodes are there, there should be a gap between these two, and whatever be the voltage gradients, means whatever be the breakdown voltage gradients, that should be reduces it should be reduces from the 3 megavolt per meter. So that is for again uniform field, and if there is a non-uniform field, that should be again 0.5 0.6 megavolt per meter. So like that way, suppose we will create the high pressure, and that high pressure gas will be provided flexible and a medium high voltage insulation. So whenever we are using the gases at a high pressures, at that time what will happen? That time we will realize whatever be the field gradients is there, that will be experienced by a 60 or we can say 25 megavolt per meter that we can observe. So there is a gases, we can say there is a nitrogen gases, and that nitrogen gases, that gas is firstly used for the high pressures, because that gas is having such kind of inertness and chemical stability, but also that is having a good dielectric strength, whatever be the dielectric strength having by the whatever our we can say that air. So whatever that dielectric strength of air, that much air dielectric strength that whatever our nitrogen gas that is having, right? So another other important insulating gas we can say that is CO2, or we can say carbon dioxide dichloro here is the dichlorofluoromethane. So that is CCl to CCl2F2, means that we can easily known by the freon gas. So again another SF6 gas that already you have studied in SGP, because that SF6 gas a circuit breaker you have understood or learned. So in that again that SF6 gas is used for the aid medium purpose. Okay, so that SF6 investigations are having a more complexity, as well as this is a heavier glass. So in the SF6 gas, we know that there is a interior stability as well as it is very good for the insulations, and it is having around 2.5 times to over to the N carbon dioxide, chlorofluoromethane, as well as we can say freon or the nitrogen. So whatever be the ratio is there, that is increasing with the pressure. So that whatever be sulfur hexafluoride gas is there, that is having very good arc quenching again property that is having. So all these point, if suppose we talk, we will think, then it is very important that whatever be the hold on a second. Okay, so whatever be the breakdown that is occurring at a high pressure, so that is again that time the gases will show the independency, and due to that what will happen, there will be a means, if suppose that gas is at a high pressure showing a independence or the dependence on the nature as well as whatever the smoothness or the smoothness on the electrode material, at that time we can say that whatever be the gases we need to examine to the date, that time whatever be the sulfur hexafluoride gas we are thinking that should be have a whatever be the dielectric as well as the arc quenching poly properties that is having in a SF6 gas. So another important medium that can be used as a vacuum. So vacuum means what? In Marathi we can say the vacuum means a pokri. Okay, so that can be used. We can say that can be used to decrease, or we can say this kind of the vacuum, whenever we are using that as a medium, at that time it can decreases to the less than 10 raised to 5 volt per centimeter for the gaps of the several centimeters. So means suppose whatever be the gap will be there, uh, that can be break down by the vacuum. So under such kind of these vacuum conditions where we know that there is pressure below 10 raised to minus 4 torr, so that time breakdown will not occur. Why? Because there should be a collisional process. As we know that what is the collisional process, I'll explain later. So that breakdown strength for the vacuum, that is very high, right? So vacuum insulation can be used for the partially accelerators or X-ray machines or a field emission tubes, or we can say electronic microscopes as well as capacitor circuit breakers. So that places that can be used. Then another one, as we know that gas vacuum breakdown, there is a liquid breakdown. So by using of these liquid breakdown, or the liquid as a insulating medium, the important parameters, or we can say the major purposes behind that is first insulation, and another is a heat conduction. As we know that liquid having a very good merits on the that it is puncturing path is self-heating. So whatever be the temporary failure, if suppose there is a over voltage, over current, overload, at that time this liquid will flow to the attacked area, and that liquid will transmit its heat. So that with that help, we can say that whatever be the discharging should be there, that should be surface, we can say the surface discharging or surface breakdown, or the solid supports, or we can say surface of the solid material that will be occurred. And if suppose we will understand the highly purified liquid having a dielectric strength at around 1 megavolt per centimeter, so that is its the highest value, right? And so, and if suppose we will see the at real value or real places, at that time whatever be the breakdown strength is there, that can be reduced if suppose their impurities will get added. Okay, so if impurities will get added, then this dielectric breakdown strength will get reduced. So in such cases oil will be used, and that is having another property, that should be having another properties while selecting a liquid for the dielectric liquid for the insulating medium. So that in having that should have electrical properties, in that it should have good dielectric strength, it should have a very good conductivity, it should have a flash points, gas content, viscosity, dielectric constant, dissipation factor, stability. So all that factors should be, all that properties should be fulfilled or satisfied by this liquid, and then only then it can be used for the insulating medium for a liquid breakdown. Okay, then we'll see whatever be the solid breakdown. So if that solid breakdown means what? means there is a some kind of the material like a mica, like a ceramics, like that way. We can say there should be a truly homogeneous materials, or we can say that should be free from the imperfections. Okay, so in such cases we know that there whatever be stresses should be there, that should be are as much as 10 megavolt per centimeter, and we can say that should be our intrinsic uh, breakdown strength. Okay, so such conditions in a laboratory we can understand for that, and that should be whatever be the breakdown that is of insulation breakdown is occurring due to the whatever what kind of the mechanical failure we can say, or suppose there is a external mechanical stresses, and due to that if suppose there is a failure, at that time this failure can be occur due to the electrical fields, and that time we can say due to the electrical and mechanical there should be a breakdown, and that is known as electromechanical breakdown. So at other hand, we can say that whatever with the breakdown occurs, that can be occurs due to the chemical degradation. So how this chemical degradation will occur? So we can say due to the whatever be a heating that heat is producing. So due to the heat production, there may be a chemical degradation, and due to that chemical degradation, what we can say? We can say that process which is having a presence of air as well as moisture in solid. So whenever breakdown is occurring, at that time sometimes there will be a fresh over, or there will be sometimes for a particular moment there will be a formation of a conduction path. So at such moments when we will see that there is a conducting path occurring, so that time we can say it is a tracking, and we can say in that tracking there will be a degradation of the material. So this is the separate thing, that tracking and a treeing. Another one thing also we know, that is treeing. So in this solid breakdown, that is that was the another point in a solid breakdown. Okay, so then I'll go for the next one, that is about the estimation, control, and a we can say, let me show you clearly. Okay, so the second is that another is estimation and control of the electric stresses. Again, what does it mean by? So it means, as already we know, that whatever be the whatever be a intensity that we have seen, that is again minus del by V, and whatever be the intensity that should be used for the flux density, and in that cases whatever be differentiation means what we know, that there is a relation between the intensity and density, that is again D is equal to epsilon E. So at that time we'll go for the divergence, and the divergence of the density can be find out by using delta V. D is equal to rho V. So in that case, we know whatever be D value is there, that we can replace here. So here we have replaced that value. Then whatever be a values of this E, that E value can be replaced like that way. So we'll get the delta, so that will become square. That minus symbol will goes to the right hand side. So del square V is equal to minus whatever be your rho by V, rho V by epsilon. So that is known as a Poisson's equation. So that may be asked in your examination, that if suppose your exam will happen offline, then this question may be asked for the 4 marks. So that will be a explain estimation and control with the Poisson, with the help of Poisson's equation. So that may be asked. Okay, so here now what we will do, we will understand that whatever be rho V value, that we will understand as there is no space charge. So due to the unavailability of the space charge, we can say that is a 0. So whole term will get 0. So you will get del square V is equal to 0. So that case, this equation will be known as a Laplace equation, right? Then second thing, if suppose we'll understand that is as a rho is equal to 0, then that will show us there will be a 0 volume charge density, and that cases it is again allowing some of the charges, and what we can say line charges, ring charges, and suppose surface charges. So how they are allowing that? Because due to the whatever be existence of single locations, that is as due to the source of field. And in such cases, whatever be that del, that already I had told you in the first introductory part, that is again as a vector parameters that are increasing with the respective direction. So again we'll take it's a Laplace equation that will be like that way. So here we know that there is a dot dot product of the two scalars that will become a scalar quantity. So few numerical methods are there for the determination of the potential value, so that are numerical electrolytic tank method. So that some numerical methods are again finite difference method, that is known as the FDM, finite element method. Then charge simulation method, surface charge simulation method. So all that methods we will understand, we have considered as a electrical estimations, and it's a control of electric stress. So in such cases, if suppose on a ground on physically, if suppose we'll see all the practically things at that time, there is a problems which are having very good important rules are there. So that rules will be used to understand whatever be the problems that are possible by using another some rules. So that rules will be what the equipotential cut of these field lines at the right angles. Then when another equipotential and field lines are drawn to the from curvilinear squares, that time whatever be the density of the field line is an indication of the electric stress controlling given region. And another last rule, that is if in any region the maximum electric field is given by dv by dx, where we know that dv is nothing but difference between a two successive equipotential. Now if suppose we will design the high voltage apparatus, and at that time we should we need to control the electrical field intensity. So that time if suppose we will not control all that things, that may happens that there should be higher stresses, and that may trigger, or we can say that may accelerate all other insulation devices, leading which cause failures, right? So whatever be the electrical field control methods will play a very important role in a overall design of the equipment. So don't ignore these such things. And another thing important is that surge voltages and their distribution with control. So what does it mean by surge voltage? So we know that when surge voltage will appear, that surge voltage will may appear whenever there is a we can say there will be a what we can say there is a sudden change in voltage, sudden change in current, that means transient behavior. So in such cases your voltages will go to surges from the original power supply, and that may happen due to the lightning or due to the switching operation. So at that moment, whatever be the surge voltages in every electrical apparatus, that apparatus to has to be depends on the whatever be values that is in it. It's a windings between whatever the phase windings as well as whatever be multi-phases machines. So in such cases, that all parameters should check this transient voltage distribution. So that should be a uniform, that should be a non-uniform. So all that concept should be considered in a whenever we will think about the surge voltages. So and whenever we'll do the assessment for the dielectric strength of the insulation against the power frequency voltages, at that moment simply in high voltage testing can be done by the generating voltage and measuring that. Okay, so that is the simple thing. That means generating voltage and measuring them, that is again simple thing. Okay, so with this note we can understand that whatever be the voltage surge voltages are there, that may be occur due to the transient behavior of the power system. Okay, then means suppose whenever we will consider the high voltage testing and whatever the component parts, or if suppose some insulation assemblies, in suppose some prototypes, we can say that is under the development testing. So that time we can say it is very important to design its information, as well as we need to find out how much it is expensive. All these surveyable data we need to find out whenever we are designing the power system apparatus testing high voltage laboratory. So whatever be the factors that should be considered, and that considerable quantity must be used for the improvement like by shaping the conductors to reduce the stress concentrations, means that is again important improvement that we can do for the avoid the surge voltages or to control the surge voltages. Then another by insertion of the high dielectric strength insulation at high stress points. And another one is that by selection of materials of appropriate permittivities to obtain more uniform voltage gradient. So all these things are important, and you should understood how to control the surge voltages. Okay, so that was again about the my first unit, and that was the part we have understood about the first unit. Then we had seen a second unit that was again related to the conduction and breakdown in a gases, and in that we have seen various gases as a insulating medium. Then we can say ionization process, Townsend growth equation, primary and secondary process, Townsend's pattern for breakdown, Paschen law, all that things we have understood. So just take a little overview on that, and then we'll go forward. So whenever we will think about the gases, so basically important gases that will comes to our into our mind, that are again nitrogen gas, freon gas, CO2 gas. So that will be the important, and SF6 gas. So that are used for the insulating media. So what kind of the other phenomenon that should be considered for these gaseous dielectrics when we will apply the voltages? So we can understand whenever my applied voltage is less or very low, that time very low, small current will flow through these electrodes, and that time whatever be the insulation that is retaining in electrical properties at that moment, we will understand another side of the coin, that is when whatever applied voltage is there, that is again if maximum or it is high, that time electrical breakdown will get occurs. Okay, that time what will happen? Electrical breakdown will get occur. So means how much, however we will apply maximum electrical stress, at that time there may be a sparking, there may be a short circuit, or these electrodes may get shorted, or the electrode get make a generate spark. Okay, so whatever be the maximum voltage that we are applying for the insulation of at the moment of breakdown, that is known as the breakdown voltage. So the voltage at which breakdown is occurring, it is that much simple. Voltage at which breakdown is occurring, that is known as a breakdown voltage. So in such cases, to understand these breakdown phenomena, there are further studies, or we can say that further studies are again depend on the electrical properties of the gases, and how it's a processes that is producing the gases, again that are very important. So whatever be the electrical discharges that are having into the gases, that is again having two types. First is non-sustaining, another is self-sustaining. So whatever be the breakdown in a gases, that should be called as a spark breakdown, and in cases of the non-sustaining, or in case of this self-sustaining, so it is known as a spark breakdown, right? So whenever due to the ionization process, if suppose there is a buildup of the high current, suppose our current is building up and due to the ionization, and at that time there will be a creation of ions near a creation of electrons. That time that electrons and ions will be created from the neutral atoms, or we can say neutral molecules. So and whenever we are creating that one, at that time their migration to the anode to cathode, that will take that will lead the highest current respectively. So there are only two theories currently, that is Townsend and another streamer theory, so that are used for the breakdown conditions, breakdowns which are occurring under the different conditions. So this is important part, we are understanding that whatever be the Townsend's theory. So before going for the Townsend's theory, there is a need to understand the ionization process. So how this ionization process will take place? So ionization process means what? Means, see, we know that this is a gas. Gas is means what? It is a perfect insulator. So if suppose we are applying a high voltage in between, suppose two electrodes that are immersed in a gaseous medium, and that time that gas will become a conductor, and then electrical breakdowns will occur. So whatever be that process is happening there, that for that process there is a reason, or there is a cause, which is ionization by a collision, photoionization, and we can see the secondary ionization process. So in such cases, sometimes we can say whatever be the insulating gas which is used as a medium, so that is playing very important role as it is a process of attachment. So we'll understand first one, that is ionization by collision. Collision means what? Means it is a bombarding from one to another. So means what? That whatever be liberations is happening there. So how these liberations will take place? That liberation means what? Whatever be electron from gas molecule that will have a production from positive ion is called ionization, right? So whenever due to the collision, what will happen? Whatever the free electrons are there, that will collide with the neutral molecule or neutral gas molecule, and then this neutral molecule will give a birth to the new electron, or we can say the positive ion. So that is the simple procedure where we can see ionization by collision. So suppose we will consider that if there is a low pressure gas in column, and if suppose electrical field that is applied across to the electrode as shown in the figure here, this is the if suppose this is one electrode, this is another electrode, and there is a cathode, anode, and suppose there is a gaseous medium, and we are applying very low pressure gas. So what happened? So at that time, if whatever be the energy that has been gained during this traveling, or during this collision, at that time we can say due to the ionization potential, or whatever be the voltage we are applying, Vi, so that will be causing that to energy dislodge from an electron, and that will occur, that will suddenly collide on another electron. So whatever be the process that is occurring, that should be calculated with the help of E electrons plus atom is whatever be the A plus means that is a positive ion, E minus means it is an electron. So electrons will produce the cathode by some external means, and there should be some UV light that will fall, and if suppose that UV light will fall on the neutral molecule, then it will give birth to the new positive ion or new molecule. So such kind of things that we will represent, that it should increase the current, and hence that current is increasing due to that whatever be the anode per unit time current is there, that will be greater than whatever be the liberations happened at a cathode level. So in such cases, whatever be the positive ions that will reach to the cathode, so that whenever it is reaching to the cathode, that will time bombard on the cathode, and that will give rise to the secondary electrons that is going to burn, right? So this was for the ionization process. Then another ionization processes I'll show you here. Okay, that has been yes. So I hope it is again visible, very good. This is the second process, ionization process, that is the photoionization. So what we will see in photoionization? So photoionization means what? In such cases, whatever be the excitation of the atom to the higher energy state, that has been considered. And another is that continuous absorption by direct excitation of the atom, or dissociation of diatomic molecular, or we can say the direct ionization is happening. So if suppose we will understand that suppose when any excited atom that is emitting from the radiation, and when their electrons are getting returns to the lower states, at the lower state, or we can say it's a ground level. So at that time, the reverse process will take place, and whatever be the atoms are there, that will be absorbed by the radiation. So whenever that is absorbing, that time we can say this is a reversible process. So this reversible process can be explained that HV is equal to plus A star. So means what? That S stands for the Planck's constant, and whatever be the C is there, that is a velocity. So like that way, it is very that much simple about the photoionization. So that ionization process can be asked for the 2 or 5 marks. Okay, and okay. Then secondary ionization process. So the secondary ionization process means what? Means the secondary electrons will be produced, and that will sustain up to a discharge after whatever be the establishment due to the ionization by collision, by the photoionization. So in such cases, that in secondary cases, electron emission will be happens due to the positive ion impact, and whatever be these positive ions that is forming here, that is due to the ionization by collision or by the photoionization. So that will get a positively charged and they will travel towards the cathode. So whenever they are traveling towards the cathode, at that time, whatever be the positive ions will be there, that will approach to the cathode, and that may get emitted the electrons from the cathode. Why? Because it is providing the kinetic energy to the cathode, and that time that cathode will emit the electrons. So whatever the total energy at the positive ion, so that is again we can say it will be equal to ionization energy plus whatever be the, we can say, kinetic energy that is of the positive ions which is collected by the cathode, that may get ejected, and at that moment whenever it is ejecting, that time another 1 second electron will get neutralized. So in these such cases, whatever be the process that is happening here, then the probability of this process will be measured by the our sigma, which is called the Thomson secondary ionization coefficient. So that is again happen due to the positive ions, and we can say its a definition should be net yield of the electrons per incident positive ions, right? So that gamma will be gamma I will be increases with the ion velocity, and that will be the, again depends on the type of material which can be used for the we can say used for the gas as well as electrodes, right? Then second, that is due to the photons. So how the electric emissions will be happens to the photons means, suppose to cause the electron to form a metal, at that time energy should become, or energy should become across the surface potential banners. So that time we know that if suppose we'll apply some kind of the photon, and that time the UV light, or we can say ultraviolet light, that will have a suitable frequency, and due to that frequency electron emission from a metal surface that will occur at a very critical condition. So that condition will be what? That Planck constant into velocity is greater than equal to the phi. So that phi is again work function of metallic electrode, and also that V can be used by relationship of the V is nothing but what? Phi by H. So that is again known as a threshold frequency. So again the values for the nickel as well as it is given here, and some for the few electron volts, that value has been explained. Okay, just a second. Yeah, so the important thing that we had seen, that is the ionization process, right? So let us understand another thing, that is about the Towson's growth equations. Then we will see the Towson's criteria for breakdown. Then we will understand the Paschen law, right? So okay, so now we'll move towards the whatever be a Paschen law that has been explained. Towson's growth equation or current growth equation that has been explained, that we will understand firstly, and then we'll go back to the Paschen law. Okay, so now first thing here we will understand that whatever be the new electrons, that is now here see the terms are very important, that N0 is given for the electrons which are emitted from the cathode. So means electrons which are emitted from the cathode, right? Then whatever be these electrons, when we can say when a single electrons that will collide with the neutral particle, that time what we have defined, that positive ion, or we can say the electron will be formed. So this is called an ionization pooling or ionized pooling collisions we had understood. But here in cases alpha, that alpha is a number of ionizing collisions. So that is again made for the electrons per centimeters, and whatever be the centimeter direction that is given by d. So here we know that alpha, whenever on a gas pressure, that time it is equal to E by P. So alpha is nothing but what? E by P means intensity by your gas pressure. So that is called as Thomson's first ionization coefficient. So at a particular distance from the cathode, we can say whatever be a electrons, number of electrons, that can be calculated with the help of further distance, that is the change in distance, that is dx. So that may give rise to the ANX dx. So means A means alpha means your coefficient, NX means your number of electrons, and dx means what? It is a distance traveled by the electrons. So here we know that x is equal to 0 and the nx is equal to n0. So we have put it that x is equal to 0. So dnx is equal to ANX, or we can say NX, or we can say N0 exponential AX. So whenever that number of electrons reaching towards the D, means if suppose our electrons will travels up to the anode, at that time the new electrons will create it. So that means before that ND is equal to D, means the distance traveled from X to the D, that means 0 exponential A to D. So in such cases there will be a new electron generation will happen, and that time every electron will be equal to E exponential AD minus 1 is equal to ND minus 0 N0, right? So at that time we can say whatever be the average current in the gap, that will be equal to the number of electrons which are traveling per second, that will be equal to I is equal to I naught exponential alpha D. So in such cases, that is again a I0 is nothing but what? It is the initial current, and whatever be the values that we have taken ND, that ND means what? ND stands for the whatever be electrons that are as per the traveled after up to the D distance. Okay. Then current growth in the presence of secondary processes, that means whenever yeah, so means a process that is becoming a complete when our electrons will reach us up to the anode by traveling the distance of D, and at that time we know that the amplification of electrons will occurs, means exponential AD is in the field, and that time whatever be the probability of additional new electrons that has been liberated in the gap with the help of another some mechanism that can be avalanched, and that other mechanisms which can be seen, that is again positive ion mechanism. So where to liberate the electrons from the cathode to anode, that time it should have to it should have sufficient energy to liberate. Then another second thing, that should have excite the atoms or molecules, so that is why it will goes and collide on others. And last we can say that should be have a metastable particles that may diffuse back whenever there is a electrons emissions will take place. So whatever be the electrons produced by this process will known as a secondary electrons, and whatever be the gamma is given there as alpha is first coefficient, but the gamma will be a second coefficient of the Thomson's growth criteria, right? So like that way we can say second, third, fourth criteria, that time second, fourth coefficient can be calculated, that y1, y2, gamma 1, gamma 2, gamma 3. So like that way we can understand each and every aspect of this Townsend's growth equation. So here, if suppose we'll follow the Townsend procedure for the current growth equation, that time we will assume whatever be n naught dash that is given, that is produced due to the secondary process, and n naught double dash that will be gives a total number of electrons leaving from the cathode. So n0 dash or n naught dash is equal to n0 plus n0. So one n0 we can write, or we can say the total number of the electrons, that is n, reaching the anode will be equal to as per the equation it is showing, n0 double dash exponential AD can be written as n0 plus n0 exponential AD, and again the values of n0 will be put on here. So there will be a equations we will got, and that is again I is equal to I0 exponential AD by 1 minus gamma exponential AD minus 1. So that will be the secondary equation for the Townsend's criteria or Townsend's growth equations. Okay. So then second things that we will understand is again, just a second.
Yeah, again important small topic is there, small point is there. That is again Clausian's criterion for the breakdown. So how this breakdown will take place means, if suppose total average current in this gap before the occurrence of breakdown. So as if suppose the whatever be the distance between that anode and cathode, that is again increasing, at that time we can say whatever be the denominator is there, that should be equal to 0. So at particular cases, if suppose we will say that D is equal to ds, at that time we will get the external source for the supply, where we will remove the value of this initial current. So if we will remove the current, at that time we can say there will be infinite, and we can say there may be a unlimited power supply in a circuitry. So that time we will understand whatever the condition is there, D is equal to ds, at that time whatever my current will goes to the infinite value, that criteria or that condition is known as a Townsend's breakdown criterion, and that can be written as gamma exponential AD minus 1 will be equal to 1. So if suppose there is a gap spacing, and at particular pressure we are applying, that time if suppose whatever be the values of alpha and gamma, that value are satisfying the breakdown criteria, that time it is known as a spark breakdown voltage, and denoted by the Vs. And such kind of the distances or the corresponding distances for the spark breakdown voltages will be known as sparking distances. So another important last thing, that is Townsend's mechanism. What explain? It explains the phenomena of breakdown only at a low pressure. So we can say whatever be the gas pressure and the gas distances are there, so that value should be around 1000 torr per centimeter and below these values. So that experimental determination for the alpha and gamma, it can be seen here in the right corner. So that time electrodes are placed here, and ionization chamber is there also. Also there is a metal chamber which is made up of the chromium plated mild steel, or we can say the stainless steel. Then guard electrode is directly earthed here, we can see here. Then electrometer amplifier, that is used here to measure the range of current, which is in between 10 raised to minus 14 to 10 raised to minus 8. Then whatever be the electrodes you can see here in a breakdown gap, there should be this should be made up from the brass, or we can say stainless steel. Also there is a high vacuum medium is provided, and that is having 10 raised to minus 4 to 10 raised to minus 6 turn. So whenever it is filling, at that time that will have a that several times it will its gas and its air will be removed, and that time whatever be the pressure that is available inside this chamber, that will be depend on the gap separation, and also whatever be the chamber is there, that will have uniformly gaseous medium for the insulation purpose. So this is all for the today's lecture. So by next lecture we'll go for the further revision part of the second unit, that may see the Paschen law, or in that Paschen law. After that we will go for the unit number 3. Okay, so for now we will stop here only, and just let me take in attendance. Just hold on a second. Okay, today again our lecture is there at 3:30. Okay, so at this lecture we will continue to the revision part on the remaining part of second unit, and the third unit, whatever be the part we will, it is there has been conduction and breakdown in solid and liquid is, so that we will go for the next 3:30 lecture. Okay, so hold on for a second. Okay, fine. So you can leave the class and join another.